Good morning, friends. Welcome to our official YouTube channel of Hasan Goswami College of Engineering. I am Gautam Patel from Mathematics Department. Now, in previous two lectures of subject CVPD, we discussed our properties and simple formulas of the complex number. Now here we take basic examples of previous two lectures properties of complex numbers. So now here we take first example. Find the value of square root minus 5. Now we know that if we find this square root minus 5 in calculator, then we get two words, math error, because computer system like a computer or a calculator not give answer directly of the square root of minus 5, but this square root of minus 5, that means negative value root is also exist, and this is solved by this method. So first we take let complex number z. Okay, because any number, any answer, it's a complex number. Either it's real or integer, doesn't matter. But it's all belong in the complex number set. That means we consider it's a z equal to x plus iy, and this equal to square root of minus 5. Okay, so we take z x plus iy, and this is equal to square root of minus 5. Now remove this square root by taking both sides squares. So taking, or directly right here, squaring on both sides. So now take only this two terms. So we get therefore x plus iy, or x square. Okay, this I is also known as a Greek letter iota. This square and square root square. So we get only minus 5. So x plus iy whole square, this equal to minus 5. Now expand this x plus iy, so we get x square plus 2i xy plus iy whole square. This equal to minus 5. Okay, so next, now we know that this multiplication of two value I and y. So take different square, so I square y square, and we know that I square is minus 1. So this x square and this value minus y square at first, plus iota I into 2xy. Okay, this equal to minus 5, because I square is minus 1. Okay, now compare both sides. So comparing both sides. Now comparing both sides. So this is without I terms. So and this is also in right hand side without I terms. So therefore we get x square minus y square, this equal to minus 5. X square minus y square, this equal to minus 5. And here with I part is, that means imaginary part is 2xy, but here imaginary part not display, but it's exist, and it's I into 0. This is I into 0. Okay, now compare both sides. So 2xy is 2xy, this equal to 0. Now from this 2xy, now 2 is a non-zero value, so taking the right hand side, so we get xy equal to 0. So from this, thus xy equal to 0. Now x into y, any two value multiplication 0, that means at least one is 0. So either x0 or y0, yeah, both 0. At least means या x 0 हो सकता है, y 0 हो सकता है, कि दोनों 0 हो सकते हैं. So that implies x equal to 0 or this y equal to 0. Okay, so this means x equal to 0 or y equal to 0. Now this our answer of the xy equal to 0, x equal to 0 or y equal to 0. Now we use this one by one in this form. So first we take here y equal to 0. Now y equal to 0, that implies, now here y equal to 0, we get x square equal to minus 5. Now any value square never becomes 0, because minus square becomes positive, positive square is always positive. So this is not possible. That means this y equal to 0 not possible. So remaining must be x equal to 0 exists. Therefore x equal to 0, that implies x equal to 0, so we get minus y square, and this equal to minus 5. That implies, now minus minus cancel out, so we get y square equal to 5. That implies, now y square equal to 5, so y equal to, now here square, so we get two values which are plus or minus square root of 5. So when x equal to 0, y two value plus or minus root 5, that means z is 0 and y is plus or minus. That means therefore z equal to x plus iy. We get first for the x equal to 0, this 0 plus I, we take plus root 5. So plus root 5, therefore one value z is I root 5. I root 5. And z equal to x plus iy, this equal to, now we take x is single and opposite side y is 2, so here one already used, so 0 minus I root 5. Therefore z equal to minus I root 5. Okay, so there are two value of z, hence square root of minus 5, we get, number one is plus I root 5, second is minus I root 5. So we combine this and write plus or minus I root 5, plus or minus I root 5. And this answer in complex form, I plus or minus I root 5. So any negative value, here if we put a minus 4, that means minus 4 square root is plus or minus I root 2. Now this is a simple example, basic example. Now we go to one more example. Depend on the modulus. How to simplify modulus and get this some proof or some answer. But here we take simple example. So if example is, if mode of I plus z, this equal to mode of I minus z, then show that it is, or show that z is real. Show that z is real. Okay, so now in solution, so we are not given that z, so let z equal to x plus iy, Okay, so now put here therefore in this, so mod of I plus x plus iy, this equal to mod of I minus in bracket x minus iy. Okay, so now therefore mod of x plus, now in this I is common, so 1 plus y. Okay, this equal to in here similarly now this multiply, so here it's a plus, so multiply inside, so minus x plus I, in this two term I is common, but here minus, so this is minus, so 1 minus y, modulus is over. Okay, now apply modulus. Modulus, that means ki real part square root of real part square plus imaginary part square. So therefore by the definition of the modulus we get x square plus 1 plus y whole square. Now this equal to, similarly here square root of minus x square is x square, or right here minus x whole square plus 1 minus y whole square. Now taking both sides square, so we get x square plus 1 plus y whole square, this equal to, now minus x square is x square plus 1 minus y whole square. Okay, because by squaring. Okay, therefore now this both side, this term is same, so cancel, x square s square cancel. Now expansion is 1 plus 2y plus y square. Now here this equal to 1 minus 2y plus y square. Now in both sides 1 is common, cancel, this y square is cancel, remaining is 2y minus 2y. This minus 2y take left hand side, so therefore we get 4y, this equal to 0. Now 4 is constant, so remaining only y equal to 0. Okay, so y is, we get 0, but doesn't matter what is x, because x is not given in this solution x is not gives any answer, that means x is any unknown. So put this y equal to 0 in our supposition z, so hence z equal to, this is 0, so remaining x, so we get z is x, thus z is real, that means z is only real part exists, imaginary part is 0. So this two example we discuss. In next lecture we discuss more example. So thank you for watching our video. Please like, share and subscribe it. Thank you.